All right, so finally we are into some actual pre-calc. Everything else, Unit 1 was a big old warm-up. There was a lot of information in there, but now we're actually getting officially started, so let's go. Starts out with this composing functions. Sounds intimidating, but it's not too bad. So first of all, they deliver it to us in kind of an interesting way. They're going to give us f of x equals 3x plus 2. H of x is explained by this crazy amount of information, and g of x is right here. So when you see this sort of a thing, you can say to yourself, okay, this is negative 2, 2. In other words, g of negative 2 equals 2. If x is negative 2, y is 2. And then you got this point right here, 2, 4. And you got this point over here, which is 3, 0. So here's your x input, y output, x input, y output. Now, and here it is again, input, output, input, output, input, output, input, output. This thing doesn't really have any numbers. It's just your equation, and that's all they give you. So what are they actually having us do? Well, there's a song by Phil Collins, and it's called Inside Out. Check it. In class, I'll probably play it really loud just to pound this idea into your head that to compose functions, you work from the inside out. Now, this sounds fancy, but let's go with letter A. This is f of h of 6. Now, there's supposed to be another parentheses right here. Now, I'll throw this in for free. Maybe on your ACT, SAT, they're going to write it like this. It's like an F. It looks like times, but it's an open circle, H, 6. These two things are the same. Remember the Phil Collins song, find this first. So the first thing we're going to do is find H of 6. So we look around. Well, that's not H. That's not H. Here's H. So it's saying if let x equals 6, find out what y is. Well, when x is 6, y is 5, according to this chart. Don't look into this chart too much, like building an equation. I threw down random numbers here, so don't try to make a connection here. So x is 6, y is 5. So there it is. Now, what does that mean? It means I can go to here and replace h of 6 with what it equals, which is a 5. And now I say, now I have to let x equal 5, that's what this is saying, and plug it into the equation defined by f, which is right here. So then I go 3 times 5 plus 2 is 17. 15 plus 2 is 17. So my final answer for that problem that I erased is actually 17. All right, let's move on to this next one. So Phil Collins tells us move from the inside out. If they give it to you like this, it's pretty obvious, g of 2. If they give it to us like this, you go here, g of 2. Regardless, that's what we have to find first. Well, this is drawing our attention to g of x. So we're like, well, where does x equal 2? Well, look at, if x is 2, y is 4. So they already told us that this equals 4. So we know that the inside equals 4. And now we're going to plug this into f. So we go up here, and we put a 4 in there. 4 times 3 is 12. 12 plus 2 is 14. So that's my answer to this, which was the same thing as this. One more. So now we're going to work from the inside out again. So we look for this. We go, okay, where's H? That's not an H, that's not an H, this is an H. So this is also saying, where does X equal negative 4? In other words, what does Y equal, question mark? Well, if X is negative 4, H or Y is 2. So we'll make that into a 2. So all that craziness in there turns into a 2. So I I need to plug this into G. Well, what do you mean? Well, we find G, which is right here, and we say, all right, if x is 2 in the equation or the function described by G, which is these dots, we would say if x is 2, then y equals 2, 4. So that 4 is my final answer to this, which was the same thing as this. So that's composing functions with a little curveball thrown on it. Another component of composing functions is when they give you a little fancy equation like this, and you can see that we know that C equals this. Then they throw us this zinger and they say, okay, solve for x. So you're not done until you have x equals some stuff, which is the clue. Do what you got to do to get x by itself. So I look at this and I say, okay, I'm going to go ahead and multiply this side by x plus 1. I'm going to multiply this by x plus 1. These cancel. I'm going to distribute this because it's just math. xc or cx plus c equals 2x minus 3. Now don't forget, we're trying to get x alone. So think for a second. Here's an x in this term. Here's an x in this term. So I'm going to get the c over here, subtract c, and I'm going to subtract 2x and subtract 2x. So I can see some factoring coming. So I get xc minus 2x equals negative 3 minus c. Now I'm going to erase this here. Look at, I got x here, so I got x, take an x out, c minus 2 equals negative 3 minus c. I'm going to divide by c minus 2, because those will cancel. But then I divide by c minus 2. I could put parentheses around there. And now I'm done. X equals negative 3 minus c all over c minus 2. And there it is. I found solved for x. What does this have to do with composing functions? Basically, originally we had c in terms of x. And by solving for x, now we have x in terms of c. So more of that is coming, but this is just a little warm-up to where this is all headed. Okay, so here we go. Pre-calc, again, kind of bounces all over the place. You kind of have to get used to that. But we're going to keep building off of this a little bit. You've already been introduced to the letter D. And so let's review that really quick. So y equals x squared. The parent function looks like this. Y equals x squared plus 3. See, that's the D. That's going to bump it up 3 units. So I'm going to make that one dotted. All right, so you should be comfortable with that. Now somebody might say, well, why isn't this C? And that answer is because there's no parentheses here. Okay, if it was x plus 3 squared, that would be our C, and this is our B, and there'd be an A there, and there'd be a D here. So no parentheses, that means it's a D. It's got to be inside the parentheses in order for it to be a C, which is a lead-in to my next type of problem. Okay, so now we're going to start concentrating on this letter C. Something interesting happens, but let me just show you. Here's a new type of equation, but remember, these rules work regardless of the type of equation. Remember, this is squared, so it's a parabola. This is cubed. I don't know if you've seen a cubed equation before, but I'm going to show you what it looks like by just plugging things in. So it'd be negative 27, negative 8, negative 1, 0, 1, 8, 27. I'm going to start with this, 0, 0, go to here, negative 1, negative 1, 1, 1, 2, 8, negative 2, negative 8, and it would just look something like this. Now this x minus 2, if you were to ask me, what does that do? Does it move it left 2 or right 2? I would go, I think it moves it left 2 because of that minus. Now watch what actually happens. I'm going to plug the 0 in just to show you something. 0 minus 2 is negative 2. Negative 2 cubed is negative 8. I'm going to plug the 1 in. 1 minus 2 is negative 1. Negative 1 cubed is negative 1. Plug the 2 in. 2 minus 2 is 0. 0 cubed is 0. So I want you to look at this point, and then this point. 1, negative 1. Wait a minute. Hold on a second. I knew I made a mistake there. I just couldn't think of it in the moment. 1, negative 1 is not here. This is 3, negative 1. So 1, negative 1 should have been right here. And you can already, let's just plug in the 3 now. 3 minus 2 is 1. 1 cubed is 1. Out 3, up 1. You can see that this minus 2 moves it right 2. Now, I'm not going to do it for you and take up all your time on the video, but if that was x plus 2 cubed, what would that do? Well, that would move it left 2. And again, you go to decimals.com and type this stuff in just to verify it. If you ever get confused, you need to be reminded of it. All right, a couple of things. And again, pre-calculus, it's all over the place. So now they want you to really focus on how to get square roots out of denominators. A couple of things you got to remember. What's anything times 1? Well, it's itself. See, 7 over 7 is 1. 1 times 2/3 is just 2/3. Square root of 2 times the square root of 2 is actually the square root of 4, which is 2. Square root of 3 times the square root of 3 is the square root of 9, which is 3. Notice if you square a square root, the roots fly off. Square root, the roots fly off. What's that telling me to do? Take a square root of 2, square root of 2, mark this diamond, and here we go. 4 square root of 2. What does that turn into? 2. Now look at this. Can that be reduced? Yes. So that would be your final answer. Over here, all I care about is the square root of 5. I'm going to multiply by the square root of 5 all over the square root of 5. So what am I doing? I'm multiplying by 1. I'm just changing the way it looks. So I get 6 square root of 5 all over. Now watch this. The square root of 5 times the square root of 5 is actually the square root of 25, which is 5. So 5 times 5 is 25. I can't reduce this, so I'm done. So I stand corrected. We're not in Unit 2 yet. We're in 1-2-1. So it gets a little confusing how this book kind of categorizes things. I thought it was Unit 2, whatever. We're getting towards the end of Unit 1, okay? So they're going to have problems where they're going to tell you to undo the function. Well, you have to realize that that just means this is y equals 3x plus 7. Notice y is in terms of x. Now they want you to just solve for x so that x is in terms of y. So we subtract 7, subtract 7. I'm going to flip this around, so 3x equals y minus 7. You can divide by 3 or multiply by 1/3. I'm going to divide everything by 3. And I'm going to get x is y minus 7 all over 3. So technically, now I've undone the problem. This is actually g of y equals y minus 7 over 3. And so now we have x in terms of y. So if we know what y is, some number like 6, we can plug it in here and then find x. But you're done when you get to here, okay? You're just switching it around, solving for x and giving it a new name because it's a new formula, a new equation. Last problem. So you've learned that these actually give you 7i. So these are imaginary numbers, which means no negatives under square roots. This problem says, what are the values for x in the square root of 4 minus x that make a real number? Well, what our brain has to think is, it can be 0 or anything greater than 0. So how do we say that about 4 minus x? You take this out, whatever it is, and you say greater than or equal to 0. And now you have an inequality that you need to solve. So I get negative x greater than or equal to negative 4. Remember, if you multiply an inequality by a negative, you got to flip the inequality. And then you can always plug this in. What's less than 4? Plug it in and see if it's true.